Hey everybody, Meteorologist Liz McGiffin here, and if you were up before sunrise the last couple of days, you may have been in store for a treat and caught part of the Perseid Meteor Shower. Now, today I want to show you an experiment that talks about meteors and meteorites, and before I do, I want to explain kind of what's going on with all those. Let's start with kind of a basic definition for what a meteor is. Basically, meteors are debris that are just floating around in space, and that debris comes from comets. And comets, simply put, are these big blobs of ice that rotate around the sun, pretty similar to how the Earth orbits around the sun. Now, as it orbits its way around, the comet will leave behind that trail of debris, and that debris is often a combination of gas, of metals, of rocks that we're able to view as meteors. Now, as those meteors work their way toward the Earth's atmosphere, they're moving extremely fast. We're talking about, in many cases, over 100,000 miles per hour. Now, when an object moves that fast, friction really starts to heat it up. And as a result, those meteors will often burst into flames instead of hitting the surface, which is good news for us because that means we get quite the lightning show or light up show thanks to those bursting meteors. And when we get several of them, that provides that beautiful meteor shower. I do want to get to what happens if that meteor actually does work its way through the atmosphere and hits the surface of either the Earth or even the moon. When that happens, the meteor becomes a meteorite. And the experiment that I have to show you how that all works is pretty simple. It involves a container that's filled up with water. I went ahead and filled up a Tupperware container, about 2/3 of the way full. You really don't have to be too particular with what you fill up for this experiment, as long as it's mostly full, whether it's a cup or a Tupperware jar or even a casserole dish. You're also going to need a few small objects, and these will work as our meteors, or eventually our meteorites. So I have a few nuts, like some almonds and pistachios here. You can use some dried fruit like raisins, and I also have just a few ice cubes. You want to make sure that you have a few objects of different sizes, and I'll show you why here in a minute. So, we already mentioned these are going to be our meteorites, and what our Tupperware container of water represents is going to be our surface. We'll call it the surface of the moon. First thing I'm going to have you do, move that to the side. I'm going to grab one of my small objects, so in this case an ice cube, hold it up above the Tupperware container and drop it in. Now I'm going to grab my camera and show you kind of a bird's eye view of what's happening. Okay, let's try that again from this angle. Again, I'm going to grab one of my small objects. We'll grab one of my ice cubes, hold it up, and then drop. Did you notice the splash? Now I want you to grab an object of a different size. So for contrast, I'm going to grab a pistachio. Hold it up to about the same height. Drop. Did you notice that it still made a splash, but this time it looked a little different? Well, that's important because meteors, as they float around in space, they come in all sorts of different sizes and shapes. So the splash that they project, or the ejecta, is going to look a little different. Now, obviously, meteors, they are not going to be coming in at the same angle every time. So again, I want you to grab one of your small objects, kind of throw it in from the side. Did you notice, again, the splash looked a little bit different this time? When it comes in from the side, maybe it's longer on one side and shorter on the other. Again, that splash that's created is something that's called an ejecta. And scientists can actually look at the ejecta, which oftentimes is not going to be a splash in the ocean like we created, but will actually be a splash on the surface of the Earth or the moon. And they can look at what was splashed up, or the dirt that came up from the ground, and get a good feeling for how the size the meteor or the meteorite was as it made its landfall. And just like what we saw in this experiment, the larger the splash generally means that it was a much larger meteorite that worked its way down to the surface. The Perseid Meteor Shower continues through most of the month of August, so if you're lucky enough to not only see it, but snap a picture of it, we'd love to see your view. The best way to send us those photos so that we can share them online and on the air will be to send them through the NBC4 mobile weather app.